Welcome, modelers. Some comments have asked for a simple explanation on how to wire up lights for a model. So I put together this basic tutorial on lighting a model. This is part 12 of my Trumpeter 1 to 200 scale Titanic build series. So the first thing that one would need are the tools. So the basic tools for helping you wire up a model and light it, you'd want to have yourself a half decent multimeter. This way you can check voltage and amps and resistance if you need to. Of course, you want a soldering iron. You can use one with a real fine point to get little spots, or just one with a general point so that you can weld up just your regular LEDs. You also want to have some helping hands. Sometimes when you have to do some of these small lights, you want to put them in a little vise here and something hold it while you're sitting there soldering the wires to the LEDs. You'll want to have some kind of, I guess this is like a copper scrubbies that you can get. And what this does is it helps keep the tip of your soldering iron clean. So before you apply new solder, you can clean it up, get all the old stuff off, and then put some fresh solder on this. If you really want to learn better techniques about soldering, there's plenty of videos on YouTube on how to solder. Make sure that your soldering iron is clean and you get the best soldering job done. And of course you'll want to have some solder. This is just plain old 6040 rosin core solder. Sometimes you might want to use some flux. So there's liquid flux. You put this on the end of the wire, and the connector, that say the LED connector, and it helps make sure that the two surfaces are clean and you get a very good soldering bond. And then they also have some solder and a paste, just the different methods. Some people like paste, some people like the liquid. And then last but not least, you want to have some kind of power source. And this is just a basic power source. This way you can test your lights and your wiring, make sure everything works. You just turn it on, and you have a current setting, and then you have the voltage setting. So right now I got it set at 9 volts, and you just turn this here and it will change the voltage. So sometimes if you want to test an LED, you might want to test it at its lower voltage before you wire it up with resistors and wires to whatever voltage you're going to use to run the model on. So that's basically the tools you need to start lighting up your model. Next, let's take a look at the type of LEDs you can use. Okay, modelers, up next is the lighting source. And typically for the lights of a model nowadays, people use LEDs. And there are various types of LEDs. The first type here is what is called the strip LEDs. And you have just a bunch of little LEDs all wired up already on a strip. And typically this size will have an adhesive on the back. You just remove the tape, and then you can tape this anywhere on the model that you want to put the lights on. You don't have to necessarily glue it, although I would recommend you still add some like hot glue to kind of secure it so that the tape doesn't come off. And then these strip LEDs usually come in two types. This is what is called double density, and that just means you have a lot of LEDs tightly packed per foot, and versus the single density, which has less LEDs on the tape per foot. So if you compare the two, you can see that the double density essentially has double the amount of LEDs per foot as the single density. So you use double density in areas where you want a lot of light in the same amount of square footage. And if you want less light, you would use just a single density. And these are good for example, if you're going to light up the hull, that's a big surface, so you just would run the tape along the area of the hull you want to start the lights, and it makes it a little easier. You don't have to wire up each individual LED. It's already pre-wired, and you just have to connect the wire at the end to get that whole strip lit up. And these come in different sizes as well, so there's even smaller LEDs on the strip. Now usually the smaller ones do not have an adhesive on the back, so these you will have to hot glue to the surface where you're putting these lights. Then you got the typical LEDs. This here is 5mm, and this has two prongs coming out of the LED. The prong that is the longest, that is the positive, and the one that's the shortest is the negative. And one thing about LEDs, if you do wire them wrong, they just won't light. Won't blow them or anything, they just won't light. So if it doesn't light, you know you've got the wires backwards. And then you got different sizes. Here's 3mm, and they also have different shapes. This is a 2mm lighthouse shape, and then they have a different shape. This is 1.8mm. And of course they come in various colors. They got white, blue, green, yellow, red. And the next different type of LED is what they call an SMD. These are very small, and these are lights you can use in little places. They're usually pre-wired, so you don't have to worry about trying to wire these little things. And some of them also have a resistor already pre-wired to them. So you got this size LED or SMD, and then there's even smaller ones. This is the real tiny one. This is the one I'm using for the deck house lights. And this one in particular comes with a resistor as well. And then some SMD lights come in packs, and they are not pre-wired with a resistor. You just add your own resistor, but they're still pre-wired. These are so small, you want to get ones that are pre-wired. And with these packs, they come with specifications. And the specification you just really want to be concerned with are the voltage range. For this SMD, it's 3 volts to 3.2 volts. That's essentially the max. You don't want to go over that. And you will note that when you get the red LEDs and the yellow LEDs, their voltage is different. They typically are like 1.8 to 2 volts. So you will have to use a different resistor to control that voltage, and we'll get into that in the next segment or so. But the next thing that you want to do too, you can use is fiber optics. And the way fiber optics work is you just have your light source from an LED or whatever, and it shines at one end of the fiber optic, and it will transmit the light to the other end of the fiber optic, and you have now a pinpoint of light. So if you're looking for very tiny lights that you want to put in some place, or a smaller model, you might want to use the fiber optics in that situation. But it does create a lot more wiring up of fiber optics than with just using LEDs and SMDs. And if you do get a bunch of SMDs and LEDs, you might want to have a little storage container where you can just put them in, just label them, and you'll just get a whole bunch of different types. That way you don't have to worry about if you have to get something special, you just have it already. They don't cost too much, so but it's a nice way to organize your LEDs. Alright, next up we will go over the wiring of, or the wires of the LEDs. Okay, next up we got the wiring that is used to wire up LEDs. Now usually the wire that you would use is this magnet wire. This is a very thin wire, that you usually would use to make magnetic motors. But you can use this as a wire. It's coated, so it's insulated. And this here wire is 28 gauge, but it's nice to use on the LEDs because it doesn't require a lot of space. So you just take an LED, you kind of would wrap that wire around, and then you'd solder it to the LED post there, and you wire it up, and then you can wire this up to a power source. Usually one would use the red for positive, and then you can use the green for negative. So that way you can tell the differences between positive and negative connections. Now some use the automotive type of wire, coated. This is 22 gauge. You can use that. If you have an area where there's a lot of wires at a junction and you want to make sure you have no resistance because of a small wire, you can go to bigger wire. And this is again just automotive wire. You can get like at AutoZone or some of the other auto parts stores, and various colors, and you get to color code your wires. Now sometimes when you have a bunch of lights, you'll want to bring everything to a terminal, so you can have all kinds of light sources wired up to one side, and then the other side you can have your power. So you could take something like this that would connect all of the terminals on this side to one spot, and then you just wire up one end with the power, and so now you have a terminal with 12 connections for 12 different circuits. And that way you can reduce the wiring you have to wire up to one power source. And of course, if you want negative, you can do the same with a negative. So these are nice little things to have to kind of reduce the wire clutter that can accumulate very easily in some of these models. If you're using some of these bigger wires, it's good to use some heat shrink tubing to insulate them. If you look at some connectors that you might use, they have these big insulating sheaths on them, and they are just so bulky. So I always take those off, and then when I wire a wire to this terminal, I use some heat shrink tube, and the space is much smaller, but it's insulated right at the connector, so that works pretty good. So you might use some heat shrinking tubing. You can get this at Harbor Freight. Same thing with the connectors. You get different sizes, and you can get those at Harbor Freight as well. So that's basically how you wire up, or the wires that you would use to wire up an LED. Alright, next let's go to what kind of power sources you would use for your model. Okay, so you got your model all wired up with wires and lights. How are you going to run that power? Are you going to use batteries? Or are you going to plug it into a wall outlet? Well, usually most of the time people will use a wall outlet. So there's various adapters you can get. Here's one from Radio Shack, and it has actually a variety of voltages you can choose from. You can choose from anywhere from 3 volts up to 12 volts. So I have this one here set running at 9 volts. That's what I have the one Star Trek model running at. But there's a variety. Now this one here is from Radio Shack. It has this end on it, so you'd have to get an end that matches that. So here's the end, and then I just soldered an RCA type of plug, and the way you would run that, so you connect this, and you can get these fittings here. So say you build like a cabinet for your model, you can get this and screw it in place, and it's secure. And then this comes from your power source, and then you can just plug it in, Now your power source is connected, and then these wires you can wire up to, say, maybe a terminal junction, and this end you'll connect a power, the positive to, and that will bring power to all 12 of these terminals, and you do the same for the negative side. So you can get this stuff on Amazon. And of course there's other power adapters you can get. Sometimes, I don't know if you in your area you have these little bargain bin places that have all kinds of junk, and once in a while you can find these just laying in the bins. And this here is for 12 volts, and it runs up to 2 amps. So when you have these big models, you want something that's going to at least have 2 amp of power. But it's already got the fitting on the end. You just have to get the female end, and then you can connect this up to your model. And here's another different one, again, just 12 volts, 2 amps. And another type, again 12 volts, 2 amps. You want to try to look for 12 or 9 volts. This depends which voltage you want to run. I run mine either at 12 or 9 volts. And then this one here, this one's actually 8.4 volts. And looks like it's 1.2 amps, so it's not as powerful, but just another alternative you can use. So that's what you can use. Again, you can get a lot of this stuff on Amazon if you want, but at the bargain place, this costs like $1. This costs like 25 bucks. But this one's got versatility. You can use 9 volts or 12 volts, and this is 2.5 amps, so plenty of power to run a big model. So that is how you would supply power to your model. Alright, next up we're going to go over the resistors. So I'm not going to do any math problems, not going to do any formulas. I'm just going to give you a basic resistors that you will use for your LEDs. Okay, why use a resistor? Well, if you remember when we were going over the LEDs, these LEDs will only work at 3 to 3.2 volts for the white, green, blue, purple, and some other colors. And for the red and yellow colored LEDs, they will only run at 1.8 to 2 volts. But if you're going to use LED strips, these run at 9 to 12 volts. So for example, if we turn the power source on here, this is running at, let's turn it down and see where it turns off at. So around 8 volts, you can see it's very dim. The camera doesn't kind of show that, but it's very dim. Not much light coming from these. So you've got to run it at least 9 volts to get good lighting, and they can comfortably take up to 12 volt if you want it to be very bright. And that's about 12 volts. So in order to use strips with the regular LEDs and SMDs, you need to use resistors. So what resistors do you use? Instead of going through all the math, just simply use 470 ohm resistors. They're rated at 1/4 watt, which is just how much power they can take before they blow up. But 470 ohm resistor for the 3 to 3.2 voltage rated LEDs, and for the yellow and the red LEDs that are rated at only 1.8 to 2 volts, you use the 560 ohm resistor. That's it. That way you can use all this combination of LEDs and LED strips, and your model will work fine, and you will have enough power, because the 9 and 12 volt will give enough power also to the whole model, because when you add up all these lights, you're going to need some voltage to keep that all running, as well as amperage. But that's that simple. If you have any doubts about the amperage, the ratings of resistors that you want, just go online, do a search for LED resistor calculator, and you can go in there, and there's a couple of them, and you can just plug in all the specifications, and it will spit out what resistor you'd want to use for your particular circuit. Alright, next let's talk about switches. Okay, now to switches. So when you have everything wired up, you have your LEDs wired up to power. Do you want to control that power with a switch, or you just want to plug it in and then everything lights up? Well, that's your choice. I like to control things. Sometimes there are even different circuits that I have on different switches, so I use a switching system. You have a variety of switches that you can use. You have rocker arm switches. They're small and large, and these happen to glow when you turn them on, so when you switch it on, it lights up also. And there are, of course, rocker arm switches that do not illuminate. Then you have your toggle switches, and again, a small version and a larger version. And there's different varieties of these, and also some light up like these, and some do not light up. You have variable voltage type of switch, and on this one in particular, this one here, you just turn the knob and it will increase the voltage. And this will be ideal if you're putting a motor in your Titanic and you want to turn the propellers, whether it's going to be something that actually is in the water or not. Mine is not going to go into the water, so mine's just show, but this will vary the speed of the propellers. And the unique thing about this setup is that it's got a switch that you can put it in reverse. So you just flip the switch, and then now this will act in reverse and turn the propeller backwards. And of course there's the plain Jane voltage regulator. You got a switch, you can, little cover to put on this here, and again this just varies the voltage, so if you use it for like a propeller, it will vary the speed of the propeller, but just in one direction. And these wire up very simply because there's no soldering or anything like that. You just stick the wire into the holes here, and then you just use a little screwdriver and you screw that tight, and they are secure and wired up, ready to go. So it's real easy to wire these circuit boards. There are also some other types of switches. Let me show you what I have on the Star Trek model. Okay, here's an example of the variety of switches one can use that I used for this Star Trek model, and I finished this a little over a year ago. And on this model I wanted to control a variety of circuits and a variety of the lights individually. So I didn't want to just have one or two switches that would just turn everything on and then turn everything off. So this way I had control of which lights I would want on at one time, or would I want them all on. I also wired up some of the phasers so they weren't going to be on all the time. Same way with the thrusters, I wired them up individually as well. So that's why there's so many switches here. I wanted to just have control over a variety of functions of this ship. So we have the main power switch here, just a simple large toggle switch, and when that goes on, the navigational lights light up. So we got some strobe lights on, we got some little navigational lights lighting up. And you can see on the top here we got some strobe lights on the rear of the nacelles and behind the bridge, and then you can see some more of the navigational lights on the top of the saucer section. I also have each section of the whole lighting system individually hooked up to a switch. So we've got the saucer section lights, we got the secondary hull lights, we got the neck area lights. I also have some of the floodlights hooked up. Well, I got them all hooked up, I should say. And they're all on individual circuits, different areas of the ship. So again, I can control them individually. I can have some on and some off if I want to. Now the bottom row here, I use some momentary on switches. So what these are is you push the switch down and the light comes on. And that light will stay on as long as you hold the switch down. Once you let it go, it goes off. So all of the phasers that I have set up, they run on these momentarily type of switches. I also have these momentary on switches to trigger sound effects. So up on here I have phaser sound that sounds for a couple seconds, and then over here I have the photon torpedo sound. It sounds as if one of the photon torpedoes are lighting up. And then each photon torpedo has lights going off too. So if you push them at the same time, it looks like you have a photon torpedo that fires off. And of course you can get a circuit board that does that too, but they get pretty pricey. There's also a switch up here that is what they call an on-off-on switch. So when this toggle switch is up, it's on for the impulse engines in the warp speed mode. So you can see up here the crystal behind the bridge area there is now kind of like a bluish color, and that just signifies it's in warp mode. And then when I have the switch down at the bottom, the impulse engines will be a different color, like an amber color, to kind of signify just impulse engine mode only. But this is what you can do with a variety of switches to do a variety of different things to kind of add some realism to your model. And if you want to have individual control over different systems of the model. So that's what I did with the Star Trek model. And the Titanic model is going to be similar, but just not as complicated and drastic. Now just one final note on switches. Now this is the switch you get with your Titanic model. It's just an inline simple on-off switch, and it's basically a 5-volt setup. So you got a little USB plug here, and it will plug into a 5-volt system. So that means too that if you use the LED strips from the kit, these LED strips are 5 volts. They're not 12 volts. So just keep that in mind if you decide to use these. I'm not using these because these are yellow lights. I don't like the yellow light look. I just went with the soft white LED look. So to me, I just like that better. But if you do use this, just remember it's 5 volts, not 12. Also, you can connect circuits. Say you need to take something apart, but you don't want to take all the wiring off. You can wire certain circuits to these little plugs here. They're just tiny little things, and you just can connect and disconnect real easy. And that makes taking things apart, if you have access to something to take apart, much easier than if you have to just disconnect everything or undo soldering. So some of these connectors make that simple if you need to do that. But anyway, that's what switches can do for you. So let's go and wire up an LED and show you how that's done. Okay, here we go. So I got my 5mm white LED. I got the posts pulled apart so I have some room to wire up. So first thing I'm going to do is wire up the positive side. So I know the positive side is this longer side here. So let's hook that up first. So I'm going to just wrap wire around. Alright, so I'm going to put this in the helping hands to hold it all together. It's all set, ready to go. So you can see that wrapped around and ready to solder. So we get our soldering iron, get it on so it gets hot. You notice that it's got some blob of solder on it. That's there to protect it. So now we want to get that stuff off. Nice and shiny. Get ourselves some solder. Dab on it. It primes it. And we just that's it. Doesn't take long. That's all on, ready to go. So you can see that's nice and soldered. Good clean connection. Now the next thing I would do right away is that I would take this hot iron and kind of get this side bare, because by doing this you melt the coating that's around that wire. Now you have bare wire, so now you have a bare exposed wire, and now you can connect power to that. And when you solder this end together too, as you're soldering, that coating is burned off and you get a bare wire connecting to the post here. Now some people do have trouble. Sometimes they don't get that all burned off, and then they don't have a clean connection and it doesn't work. But if you take your time, I've had no problem so far, but some I have seen in their videos that they used to use magnet wire and then they went to other wire that's same gauge. This is 28 gauge magnet wire, but they do have 28 gauge and 30 gauge wire with a typical vinyl coating over top, and then you just strip that off and then you have bare wire. But I just like the magnet wire. It's easy. Alright, so we got that. So next, let's get the negative side. First thing I'm going to do is put the resistor on it. I know I need a 470 ohm resistor, but what if I didn't know what this was? Well, you could take your voltmeter here, put it down to ohms. Oop, there we go. And I got 200 ohms, and then I got 2000 ohms. So it's going to be more than 200, so I'm going to go to the 2000 scale. Turn it on. And let's see, I think you can see that. Doesn't matter which side you put the probes on. And you can see we're reading 468, so basically 470 ohms. So that tells me that this is a 470 ohm resistor. So we know we got the right resistor. Next we need to put this resistor on here. So easiest way to do this, same thing, just kind of spin it around. Okay, I'm going to hold one end, so it's secured. So I got the clamp on the resistor and the post, so everything's secured. And again, I'm going to clean off the old solder, because the old solder right now is protecting the soldering iron, so that's why you want to leave it on there after you're done. So now I want to get it off because it's old, it's oxidized. So you let the soldering iron heat up. It's nice and shiny, so we got a nice surface. Gonna put some new solder there, and then we'll solder okay. Not the nicest looking one, but it's solid. It's on there nice and secure. So now we can go to the other end, and we're going to wrap some wire around this end. And of course, to do that, we're going to get our green colored wire to signify it's negative. And we'll wrap it around. Secure it. Since this is long enough, we can secure both ends. Same thing. You can see we got solder on there. It's old, it's starting to oxidize on the outside, but it's protecting the soldering iron on the inside. So we want to get it off. Get a fresh new surface, nice and clean. You can see it's shiny. That means it's clean. Put some fresh solder on there. That kind of cleans it more. And then we're gonna solder. Just enough. Let it cool. And while this is cooling down, I'm gonna take this off. And I'm going to run this here. Make sure I burn off the coating. And that's nice and secure. So that is done. Now you can take what they call liquid tape. You get it at the automotive stores, and sometimes if you just put that liquid tape over here and coat this area, that will insulate it. You can also cut these resistors a little bit, make them shorter so that they don't stick as long. This depends on what length you really want, and sometimes you just want to make sure nothing's sticking up. But that's how you solder an LED. So let's check it. Always check. So we get our power supply. We want to get our power supply way down just in case. So we know that 3 volts is the max. So let's hook this up. And when you put the resistor on, you can put it on the negative side or the positive side. Doesn't matter. Some prefer negative, some prefer positive. I just always put it on the negative side. Hook up our light here. And there we go. It's lighting up barely. But we can now take it to 9 volts. And as you can see, it's lighting up pretty nice, and it's not blown. You go up to 4 or 5 volts without a resistor, it will blow right away. So we know that the resistor is working good, and I could take this up to 12 volts if I wanted to, and it would still shine. without blowing, the bulb. But it would be brighter, and it may not last as long. These will last maybe 10 years, but your life expectancy goes down the more power you use, and the more you get closer to that max limit of 3.0 volts to 3.2 volts. And you can take a voltmeter and check, one side will have 12 volts or 9 volts coming in, the other side will have less coming out. So that's how you can tell what actually is the voltage is actually here versus what the voltage is back here. But that's getting technical. I don't want to get technical, but that shows you a 470 ohm resistor works fine for an LED that has a 3 to 3.2 voltage limit, and it's running on 9.2 volts, so it's running fine. It hasn't blown. If it was too high, it would have blown right away, and believe me, I've already done that. So that's how you hook up your LEDs. Now, if you wanted to hook up your LED strips, you're going to need to use a fine tip soldering iron to do that, because this is a very small area, and you can see how it's got a little dab of solder right at the connections right there and there. So the first thing you do is you make sure the area is clean. This is where you might use some of that flux. You could use the paste, or you could use the liquid, and make sure these surface contacts are absolutely clean. This is what it looks like before you put soldering on it. So you make sure those contacts are nice and clean. They're labeled positive and negative, so you know which one will need the negative and which one will need the positive. And remember, this is the type that does not need a resistor. So the first thing you would do, you would take some solder, put it on your soldering iron, and just dab that area and get some solder on it. So get some solder on both ends. You put it in your helping hands and put the wire right there so that it all lines up and stays there. Or sometimes what I've done is I'll put it on something like this here that is just a tile, and tape everything in place. So I tape the wire down, tape the strip down so that it doesn't move. And then once I have it over there, I get my soldering iron, and then I just heat it up enough so that it melts the solder, and then the wire just sinks right into it, and then let it go. And then that's how you solder these strips. It takes a little more skill, but just take your time, and you'll be able to do it without no problem. So just to repeat, so first you make sure the surface is clean. You put a dab of solder. You can do one at a time or do both at the same time. And then you want to make sure that you have a bare strip. It's easier if this is already stripped bare, but just a little bit of the end is all you need stripped. And then you can just take some tape, make sure it's lined right up. So say my fingers are the tape. You got the little dab of solder right there that the wire is sitting on top of, and now you're just going to take your soldering iron. It's going to be hot enough, and you just hold it there long enough that it melts, and then you let it go, hold it, it solidifies and seals, and then you're done. You got a good tight solder. And then that's what you got here. You'll see that you have a nice little dab of solder, and the wires are secured. That's how you solder the strips. So that's basically how you solder LEDs. Hopefully that wasn't too complicated. You can get your LEDs and your magnet wire either on Amazon. Sometimes you can get a better deal for magnet wire on eBay. That's where I got mine. It just comes in these spools. And I've used a little bit of this. I mean, this is 1,000 feet, so this will just last you a long time. But just 28 gauge is really plenty of gauge for this kind of lighting work. Another place that you can get some of these supplies is HDA Model Works. And Works is spelled WORX.com. So HDAModelWorks.com is another source. They're a little more expensive. I think that some of it is because some of their LEDs or SMDs come pre-wired with resistors, so they take the time to do that. So it's about twice the price that you can get on Amazon. So if you don't mind wiring resistors to the small wires of the SMDs, which the wires are even smaller, you can just get them on Amazon for half the price. Resistors don't cost much at all. You get a bag of 100 or 500, just a couple bucks. To conclude this tutorial on wiring up an LED, I would recommend that you make some wiring diagrams of how you wired up your model. And the reason for this is when you close up that model, you may not remember exactly how you wired up that model. So by putting things down in a diagram, you have an idea of how you did that, so that when you maybe want to decide to do that model again and make some improvements. So by having a wiring diagram, you can see what weaknesses you may have had and you wanted to improve on them, and you may see what were good ideas and strengths that you would want to remain the same. So for example, here is one of the simple diagrams I made for this Star Trek model. And this is just a diagram of the 4 strobe lights that were on this model. And I labeled what LEDs I used. So on this one here on the bottom, it's a 2mm white LED. I labeled where I put the resistor, and then how I ran the wires to a point where they all connected, and then from that connection point the wires ran to the circuit board that controlled the timing of all 4 of those strobe lights. So some diagrams were simple, some diagrams get a little more complicated, and then they get real complicated, and then you can make, like on this here is kind of like a master diagram of this model. So with all these switches I had, I wanted to make sure that I knew exactly where the wires went for each switch in case I had to fix something. You also might want to have a master list so that you know what each circuit is for. And then you have the wires in your model, you want to label them too. You could use numbers, you could use letters, and then you have a master file that shows what those letters or numbers represented. So that's just something I'd recommend that you do, especially if you're going to do a lot of lighting on a model and have a lot of switches. You'll know exactly what you did if you have a wiring diagram. And if you have any questions, you just feel free to leave them in the comments section. But just remember, I'm not a professional at this, so you can search on YouTube for some of the professional model makers. They've got some amazing models, and they have some amazing lighting effects that they have done with these models. So consult some of them, get some ideas of how they did some of these models, and just go from there. Alright, that's all for now. You have a great day.